Asthma. It comes straight from an ancient Greek word that literally means panting. It's just so perfect, right? It perfectly captures that universal feeling of gasping for air, connecting a modern diagnosis to a sensation that people have felt forever. So, what is it that's causing that panting? Well, here's the surprising part. It's not really a weakness in the lungs. It's actually the strength of your body's own defense system, but it's kind of turned against itself. At its absolute core, asthma is an immune system overreaction. So, how does that work? Think of your immune system like a high-tech security team for your airways. Now, most of the time, it's great. It knows a real threat when it sees one. But with asthma, it's more like an overzealous security system. It sees something harmless, like a bit of dust or pollen, and just completely freaks out, sounding all the alarms. That's what scientists call a type 1 hypersensitivity reaction. Okay, so let's follow the dominoes as they fall here, step by step. It all kicks off with a little scout cell, a dendritic cell that finds something totally harmless, like pollen, and mistakenly flags it as a dangerous intruder. It then shows this threat to one of the big bosses of the immune system, the Th2 cell. This wakes up the Th2 cell, which immediately starts blasting out alarm signals, these chemical messengers called cytokines. One signal, IL-4, tells the body to mass-produce antibodies that go and arm these guard cells called mast cells. At the exact same time, another signal, IL-5, activates a whole other squad of immune cells, the eosinophils. So now you've got these armed mast cells and activated eosinophils ready to go, and they just release a flood of chemicals that spark this massive wave of inflammation. It's a total false alarm that leads to a very, very real battle.
And that whole cellular chain reaction, it has immediate and very real consequences for your airways. So let's look at how this false alarm actually unfolds into what we all recognize as an asthma attack.
You know, an asthma attack isn't just one event. It really happens in two phases. First, there's the early phase. This hits within minutes. The muscles wrapped around your airways just spasm and squeeze down tight. At the same time, your body starts pumping out a ton of extra mucus. All of this narrows the airways, and suddenly it's really hard to breathe. But it doesn't end there. Hours later, the late phase kicks in. All those immune cells we were just talking about finally arrive on the scene, and they start releasing chemicals that cause actual physical damage to the delicate lining of your lungs. And this is the really crucial part. While the symptoms of a single attack might go away, the long-term effects of this chronic inflammation are no joke. Over years and years, this constant cycle of damage and repair can lead to permanent changes. We're talking scarring and fibrosis, which thickens the airway walls and makes them permanently narrower. And that's why managing asthma properly is so incredibly important.
So we've seen what happens, but that leads to the next big question. Why does it happen? Let's shift gears a little and look at the causes of asthma and the common, everyday things that can trigger an attack.
Asthma definitely isn't a one-size-fits-all thing. When it shows up in childhood, say before age 12, it's generally thought to have a much stronger genetic link. If it runs in your family, your risk is just higher. But when asthma develops in adulthood, it seems to be more about the influence of your environment and all the different things you've been exposed to over a lifetime. And as you can see, those environmental factors can be almost anything. Triggers can be everyday things like air pollution from cigarette smoke or car exhaust, or common allergens like dust, pet dander, and mold. But there's also this really interesting idea called the hygiene hypothesis. It basically suggests that in our super clean, sanitized modern world, our immune systems just don't get exposed to enough germs and microbes when we're little kids. So without that early training, the system never really learns to tell friend from foe, making it way more likely to overreact to harmless stuff later on. Pretty fascinating, right? Okay, so knowing what causes an attack is half the battle. The other half is all about empowerment. It's about understanding the strategies out there to control symptoms, prevent attacks, and just live a totally full, active life. And the first line of defense is often the simplest one, avoidance. This just means taking practical steps in your daily life to cut down your exposure to the things you know are triggers. Simple stuff, right? Regular vacuuming, maybe getting rid of carpets that trap dust, controlling the humidity in your house to stop mold. These small actions can make a massive difference. Then, of course, there's medication. And asthma treatments usually fall into two main camps. First, you've got your fast-acting relief meds, like that emergency inhaler everyone recognizes. These are bronchodilators, and they work super quickly to relax those spasming muscles around your airways.
But then you have long-term control medications. These are things you take every day, not for an emergency, but to tackle the root cause, that underlying chronic inflammation that makes the airways so twitchy in the first place. Which brings us right to our final thought for today. We've journeyed deep into the lungs, and we've seen that asthma isn't really a disease of weakness. It's an overreaction of a powerful, healthy system that's just doing its job a little too well. And that leaves us with a really fascinating question for the future of medicine. If asthma is basically a learned response, how might we, one day, be able to retrain the immune system to finally tell the difference between a real threat and a false alarm? Something to think about.